Hello again, everyone. So we're going to be working on problem number 43 now from page 200. So on this problem, I'm going to choose to work on the left side, and I'm going to start by changing my cotangents into tangents. So one of the things that I notice here is that I have tangents on the right, cotangents on the left. So I'm going to start to change my cotangents into tangents. So I'm going to do 1 divided by tangent of alpha plus 1, and on my denominator I'm going to change this to be 1 divided by tangent alpha and then minus 1. So if you notice, I have kind of a messy thing on my numerator and my denominator. I'm going to try to get each of these to be one term. If you think about way back, when you add fractions, you need to have a common denominator. So that's the route that I'm going to go with here, is I'm going to try to get the denominator to be common. So when I do that, I'm going to be multiplying this 1 by a tangent of alpha over a tangent of alpha. And over here, my denominator is also tangent of alpha, so I'm going to multiply this term by tangent of alpha over tangent of alpha. And that's just so I can get a common denominator so that I can get my numerator and my denominator to be one term. So if I think about what's happening now, I have 1 plus tangent alpha over tangent alpha on my numerator, and my denominator I have 1 minus tangent of alpha over the tangent of alpha. So every once in a while when you're working with identities, it's a good idea just to kind of take a look over to the other side and kind of see where you're headed, make sure you're going in the right direction. So I noticed that over here on my numerator I have a 1 plus tangent alpha on my right, and on my denominator I have a 1 minus tangent of alpha on my right side. So I think I'm headed in the right direction. When we divide a fraction by a fraction, we keep the numerator, which is 1 plus tangent of alpha over tangent of alpha. We change the operation from divide to multiply, and we multiply by the reciprocal of the denominator. So I'm going to multiply by tangent alpha over 1 minus tangent of alpha. And if we notice here, our tangent of alphas are going to cancel, and we're left with 1 plus tangent of alpha over 1 minus tangent of alpha, which is exactly what we wanted here on the right side. And so we've proven our identity on this one here. So we're going to try one more. We're going to look at problem number 61. And on problem 61, we have secant to the 4th power of s minus tangent to the 4th power of s divided by secant squared s plus tangent squared s, and all that is equal to secant squared s minus tangent squared s. I'm going to work with the left side. That appears to be more complex, so we have a little bit more to work with. And when I look at these terms, I see 2 perfect squares, and it's a difference of 2 squares. So I'm going to think back to my difference of squares factoring, where I'm going to have secant squared s plus tangent squared s times secant squared s minus tangent squared s. And that's my numerator. On my denominator, I'm going to have secant squared s plus tangent squared s. So notice how these 2 things are the same. They are going to cancel out. And what I'm left with is secant squared s minus tangent squared s equals secant squared s minus tangent squared s. And we've just proven our identity. So some things to look for sometimes when proving identities is see if you can factor, because sometimes the factors will cancel out and then you can simplify. That's it, folks. See you soon.